Good afternoon, everybody, and welcome to the Kennedy Space Center. My name's Jason Townsend. I'm NASA's Deputy Social Media Manager, and I'd like to welcome you to today's program for the NASA Social. We're here to celebrate the journey of the Atlanta Space Shuttle as it moves to its final home. This is the last NASA Social event of the Space Shuttle program. It's kind of incredible where we've come from here. It all started many years ago in 2009 out at JPL for the very first NASA Tweet Up. Since then, we've grown and expanded from just being a Twitter-based program, and we include more and more people now from other platforms such as Facebook and Google+. We're excited that we're able to bring these behind-the-scenes experiences to everybody who follows us and who's our fan on all of our social media platforms. It's really a chance for us to show exactly what we have going on, pull that curtain back, and kind of put a nice face on what we have going on here at NASA. The thing that's really interesting about this is that the connections that are built in the community that's made out there on social media. It is really interesting to see exactly how the community's grown. We've had over 800 people who now are alumni of the NASA Social program. And to this day, several of them are still very actively involved online in sharing the space news that we as NASA are generating. It's an interesting time for the agency. We're looking at growing and going to new places and doing new things and developing new technologies. So today we're going to share a little bit about what that transformation has been and where we're headed in the future. So without any further ado, I'd like to welcome everybody, and first off, to welcome you to Kennedy Space Center is the Director of Public Affairs here, Ms. Lisa Malone.
Thank you, Jason, and it's my pleasure to welcome all of you here to Kennedy Space Center. As Jason mentioned, we've had several successful social media events here at Kennedy, and everyone who comes and participates really enjoys it. They like to learn more about Kennedy Space Center and see what's going on here. So you're going to hear a lot and see a lot today, and hope you enjoy it. And please ask questions along the way, and just enjoy everything that you're going to see and learn. Some of the things you're going to hear about today in this briefing are about how Kennedy Space Center is transforming to become a multi-user facility, and how we're going to be facilitating commercial space companies to use the facilities here. And also the next program that NASA has, which is the Space Launch System. You're going to hear a little bit about that as well. And then you're going to hear about a program that Kennedy has had for many years, the Launch Services Program, that is still active. We're launching rockets that look out into the deep space, look back at Earth, and of course go to other planets in the case of Mars, which some of you may have participated in some of those social media events as well. So we'd like to start it off with a video, and then we'll get right into the presentations.
So today we've got several presenters who are going to be talking some about what you've just seen in this video here. First up, we're going to have Scott Colorado, the Chief Architect of the Ground Systems Development and Operation Program here at Kennedy Space Center, to talk about what's being transformed here.
Thank you. Okay, hopefully that video was useful to you. I understand y'all been around a little bit here at Kennedy, VAB today and the Visitor Center later and around a little bit. First of all, my name is Colloredo. You're going to see that again later on today. My better half will be speaking to you as well. So if that sounds like a coincidence, we're not like all half-named Colorado here. That is, it's no coincidence. So, and spell that right because my mom will really appreciate being able to find me if you do any twittering or anything like that, or tweeting, I guess is the right term. So yeah, I am the Chief Architect. A lot of what you just saw in the video is the kind of thing that we're working on. We work on launch pads. If you're familiar with the way we're set up here, it's the massive VAB. That's where all the big pieces come together. They get stacked on what's called a mobile launcher. A big item, the original rover. I keep seeing this little rover that apparently has got a lot of press in the last couple of years, which is great. The big one that we have here, the 5.5 million pound one, we developed that here, and we're actually going to reuse it for the next program. So kind of jumping out of script a little bit. Probably talk first, I know you're going to hear from SLS, the Space Launch System, right? And I think later I heard Orion spacecraft, right? So I guess what I probably like to tell you about, not to steal their thunder, is to tell you a little bit about the rocket, just to show you that it's what we call an inline configuration. The spacecraft is in line with the vehicle, and he'll tell you all about it, I'm sure. It is different from shuttle. That's probably the main thing to cover. It's shuttle is what we call a side mount, where you see the big orbiter, the spacecraft, which you're all here to see tomorrow, is mounted to the external tank in such a way as you see in this model. Over here you see that what we're dealing with now. So it's dramatically different from that standpoint. It's a lot of the same components, which I'm sure will cover. From our standpoint, from the ground, our main purpose in life is to convert Kennedy to support this rocket. We're doing some other things as well, but the main thing is to convert Kennedy to launch this rocket. And this giant mosquito that you see on here, I don't know, I guess that's about 12 feet long if you scaled him up. Looks like an old, one of those monster movies. So anyway, this is the rocket we'll be launching, Space Launch System, and our purpose is to transform Kennedy. And I'll talk a little bit about what our approach right now is, and kind of big picture from what this video showed you a little bit, is our exploration enterprise, we call it, where we have 3 programs: the Space Launch System, the Orion multi-purpose crew vehicle, and the ground systems development operations. We're all working together to create this capability, where as a system we can go virtually anywhere. You know, I think most of you follow this kind of thing are familiar. You know, shuttle's gone to low Earth orbit the last 30 plus years, and that's been great. It's an awesome program. You know, now that it's retired, we have the money to develop something to go beyond that. And you're going to hear about other low Earth orbit enterprises, but our focus is beyond low Earth orbit. And the ultimate destination, if you've heard an administrator talk about it, is Mars. That's a big deal. That's where we ultimately want to be. We haven't yet determined what path we'll take to get there between now and Mars. I think right now the plan is to develop the capabilities to go just about anywhere. We can, as it showed in the video, Phobos, to go back to the moon, at least in what they call cislunar space, where you orbit the moon. Various NEAs, near-Earth asteroids, or other opportunities. So we're looking at all those. Meanwhile, we're already making progress developing the launch pad, the vehicle assembly building, the mobile launcher, which I'll talk a little bit about. Did you see the MLPs today by chance, the mobile launch platforms? Everybody point to big steel structures. We had 3 of those for shuttle, had kind of a higher flight rate. We flew more often. What we're now building, if you saw the big one north of the VAB, I have no idea what direction that is from this room, but somewhere outside here, the big tower that's just outside the VAB, that's where we actually originally built that for Ares 1. Since that program was canceled, now we're converting it for the Space Launch System, so we're excited about that. Kind of have a big 5 we like to talk about, which is the mobile launcher. It's a kind of the key piece. The other 4, the launch pad, 39B, the VAB, I always lose these. I have to write them down to remind myself when I get in front of people. All the crawler transporter and the firing room. Out of those big 5, 4 of those we're designing as multi-purpose. So virtually any rocket that looks anything like this would be able to launch from Kennedy. And so that's really our focus now, is make it evolvable, because I'm sure it'll tell you about how this will evolve from different configurations. But we also want to be able to support other users, because as of now we're launching this less often than we like, and certainly less often than shuttle. So our plan is to fill those gaps with other users potentially. We're also developing, at least we have plans to develop, we're in the design of the shuttle landing facility, if you're familiar with that, the SLF, where shuttle landed all those years. That job is now done. We're looking at converting that. We actually already have 1 user signed up, so they're actually going to be doing the future is now kind of thing, where horizontal launches and landings will be occurring out there. We have 1 user signed up officially, and we're working on 3 or 4 others. So a lot of people think about 39A and B. Once you get familiar with Kennedy, that's kind of our main area, our flagship launch sites, but we're really looking at turning the SLF into a 3rd one. So we're excited about that as well. And so again, we're converting to a multi-use capability. It's a term we use. You know, we're shuttle focused for the last 30 years. Now we want to allow ourselves to think about other things, and commercial users from any other program are able to come here and ask for our services, and we think we can provide that. So I don't know, is it too early to ask for questions? I got some more things to say, but do you have any questions at all? Wait for a microphone here. Oh.
Can you tell us the user that want to use, or is that not, you can't tell?
Yeah,
anything?
it's official, it's public. It's a company called X-Core. It's a horizontal launcher, and it's basically a fully reusable single stage to suborbital vehicle. And they're already test flying various configurations out in Mojave Spaceport in California. And they've officially signed, I'm not sure exactly how the agreement's written, but they're officially signed with coming to Florida with a combination of Space Florida and Kennedy Space Center. So we've actually got an office here called the Center Planning and Development Office. We work closely with them, and they nurture those capabilities. And X-Core is the first one. And I can tell you, I think it's pretty public. There's some others, like Stratolaunch is one that's talking to us, and there are others out there that are considering coming here. So we're excited about that. Any other question? I've got one if you don't have any. I can fill my own time if needed.
Hey Scott, thanks for spending time with us today. I guess a question for you in the ground systems work that's going on. What do you see the biggest challenge for the program between now and 2017 with the targeted Block 1 launch of SLS?
I think the biggest challenge has to be affordability, and that's really our goal is to make this more affordable. You know, government is not known, quite honestly, to be efficient or to be cheap, I guess, or efficient. We're more optimized around being fair. So trying to be efficient and fair at the same time is tough. We've got an expression we use a lot, you'll hear a lot, called flat is the new up. That's our budget now, and honestly, flat is almost the new down or down is the new up, so to speak, because correcting for inflation, we're actually losing over time as far as what our budget is. But so traditionally, and I don't know I guess y'all can see this, and I guess we're used to talking on telecons and making hands and then nobody can see them, but a traditional development curve has a big spike in it where you're doing what we're doing now. It's not much you see, and people, by the way, think we're closed out here, which couldn't be further from the truth. We get that question a lot, so anything y'all can do to dispel that myth, I hope you're seeing a lot of progress going on out here. But what you'd like to have in the initial part of a program is a nice big spike to develop the facilities, develop the rocket, develop the spacecraft, everything, and then it smooths out, and operationally you can kind of flatten out and get into more your long-term recurring costs. But we've been given this flat as the new up kind of thing, and so we're having to develop more serially than we'd like. We'd like to just hit it hard and be done with it, but the way it's set up is we don't launch till 2017, so basically our budget is flat until then, so we'll develop between now and then. But that's easily the biggest challenge, is making it come in on budget, and then right behind that is schedule, because schedule is very important to us. We have to make that date in 2017.
Questions?
Okay. Anybody want to know how much the crawler can pick up? That was one that's always a good one, Do you want to know? Anybody? Okay. It can't be a NASA employee that's asking me the question, I don't think. I think that's illegal. No, that is one kind of gee whiz. I always have people guess, and they'll guess about, 300,000 pounds or a million, a big one, or 50 tons or something. But when we rolled out shuttle on an MLP and all the way back to Saturn, which is the same crawler that we have today, it's right around 12 million pounds is what we have to pick up with the crawler. And the cool factor here with the SLS, it's a bigger vehicle, it's bigger rockets, heavier weight, more on the launcher to support all that. And we're actually redesigning Crawler 2. We have two crawlers. Crawler 2 is being redesigned to handle 18 million pounds. So it's another 50% more capacity. And it's kind of like a lot of things we're doing, clean pad, where we're making it very generic. The plan is to make everything just as capable as possible, so that if another vehicle comes along, we don't have to make any big changes. Okay, there's a question? I guess I can't ask my own questions anymore.
On 39B and I suppose maybe eventually 39A, do you actually have any known interested customers or users in addition to NASA for either 39A or 39B?
Yeah, we have. Now those we can't really talk about, but it's known and interested, yeah. Approved, that's a bigger, because it's actually somewhat revolutionary to design a multi-use launch pad at that scale. We're talking, our Marshall guys call this a heavy lift. This is really a super heavy lift, way bigger than anything we do around here or have ever done other than Saturn V, really. And so to do something like this multi-use on that scale is pretty novel. And the comfort level and lining up everything at the right time and the right opportunities is tough. But we are talking to several companies about it. We have been, and we'll continue to do. We don't have anybody signed up yet, but we expect to. And just for your information, those that aren't as familiar as James is, 39A is still in shuttle configuration. If you went out there, you see the rotating service structure, fixed service structure, all the shuttle-specific capabilities. We're leaving those in place. The way we're doing a lot of things is we're leaving essentially one string in shuttle configuration and one we're overhauling for SLS. And so there's, depending on the company and what their use is, they're more interested in A or B. So we're still talking, but we have nobody signed up yet.
Could you elaborate any on 39A? And you've talked about that, or KSC has talked about that as becoming a quote-unquote commercial pad. In what way will you make that pad available to other users? Will it be given to a company that steps forward to ask for it, or is it also a multi-use pad?
It's probably a better question for CPDO. I think I can wing it a little bit. I mean, it would also be multi-use, presumably. I mean, You know, one thing about it, it took us about 5 or 6 years to build 39A in the first place, and that was back in the 60s when you just had free reign on budget and environmental concerns and all that. So we're really humping it to get it built. So we don't want to repeat that again. So we treasure those two, even though we don't need 2 launch pads for SLS because the flight rate's lower. We are holding on to both of them to some extent. But so they are talking agreements and things like that. But we want to be as flexible as possible. So I would say that more than likely it would be open to multiple users. And I don't know how the specific agreements and all would be written, but we're not inclined to dedicate it to one thing and forevermore be that. I think our gut feel is that we need to keep it as open as possible. So again, I would say virtually everything, the crawler, the firing rooms, the launch pads, for the most part. The mobile launcher is the one thing that, just to kind of go back to that, it's so close to the vehicle and has to be so specific to the vehicle's needs. That's the one thing we struggle with, to being as open and generic and multi-purpose as everything else, but everything else we're going to try to keep that way. Now, if it comes a point in time where it makes more sense to dedicate it, we may do that. So, okay?
Last
Yeah.
question.
You talk about wanting more partners with the launch capability. Are you looking at specifically U.S.-based, or are you also looking at international partners?
When you say looked at, we wait till they come to us. We put out, or actually our CPDO friends put out a notice of availability, it's called, and various things to tell the world that we're available. So far, they've only been domestic. But if an international came to us, we would be open to that. I mean, obviously, it'd be more complicated and, you know, relations and things like that. But physically, like I say, we're trying to build this. And just to highlight a couple of you said last question, so I can make my answer as long as I want, right? I can buy more time that way. But one of the things you'll notice if you go by the pad, what we call the universal lightning protection system. There's 3 towers and catenary wires that provide a Faraday cage protection. That protects any rocket, even bigger than this, on down. Basically, if it rolls out of the VAB, we can protect it with the lightning protection. We've also just been able to officially say that we've designed a multi-use or a universal flame deflector, which is kind of a big deal. At the bottom of the rocket, especially the big rockets, they need a lot of directional thrust help, so you don't want it just reverberating and creating a pressure wave and foreign object debris and all that coming back at the rocket. So for the first time, as far as we know, and particularly on this scale, we've designed it to be universal, so practically any vehicle could launch off the pad and be fine. So those kind of things we think will enhance the capability that virtually any rocket, at least a vertically launched rocket, would be handled from Kennedy, from 39B. Okay?
All righty then.
All right.
Thank you
Thank
very much.
All right. Thank you.
So I hope everybody's following along online. If you are, our hashtag for today's event is #NASASocial. And you can also use, for the Atlantis move that's happening tomorrow and everything, you can use #Atlantis. And we are streaming this online on the media channel of NASA Television. So hopefully you guys are watching online as well. Next up, we have Tom Erdman. He's the Deputy Manager of the Space Launch System Resident Office here at Kennedy Space Center. So, Tom.
Well, thank you all for coming. So I've been working for NASA a little over 20 years, and I've been fortunate enough to work on the space shuttle and also the International Space Stations and a number of payloads that have flown. And so now we're starting to look at the SLS vehicle. This is a bad boy. This is going to be bigger than any rocket by far we've ever built in this country or in the world. And we're trying to focus 100% on affordability and sustainability. So when we first talk about affordability, trying to keep within, as Scott said, a flat budget or reducing budget. We try to leverage off the old shuttle hardware knowledge that we've done. As you can see here, the shuttle has 2 solid rocket boosters. There are 4 segments, so we're going to look at, for the SLS, we're going to have 2 solid rocket boosters that are 5 segments, so increase the thrust and the performance of the vehicle. Space Shuttle main engines are RS-25 engines. You have 3 of them on the shuttle. Here we're going to leverage off that. We're going to have 4 RS-25 engines. The external tank, we're using the same facility up at MSU to use the same technology and the same resources to build the core stage here. Now, the core stage is going to be redesigned by Boeing. The contract's being reviewed now. And then for the upper stage, we're leveraging off the Delta IV. The Delta IV ICPS, it's called, the Interim Cryogenic Propulsion System. We're going to modify that to man-rate it. So that'll be a first Block 1 engine, they call it Block 1 rocket. Then we'll make it sustainable, so we'll upgrade it over time. And eventually we'll change out. We have a RFP out now for advanced boosters to give us, again, more thrust. The upper stage will be changed to a J2X engine to give us more capability. And the final goal is to be able to launch up to 130 metric tons in the low Earth orbit. And if you look at the power that she's going to be able to put out, you're talking about 8.4 million pounds of thrust at liftoff. And try to put that in perspective for all the car buffs out there, that's equivalent to about 160,000 Corvette engines firing all at the same time. Then the common question is, why do we want SLS? What does SLS buy? Why is America going to invest this money in this vehicle? You know, right now we have, as you'll hear, the commercial crew folks. They're going to be launching folks in the low Earth orbit. You know, they get up to the space station. Space station at any given times between 220, 230 miles above Earth orbit. You know, but if you want to go in a deep space, you need a big rocket to launch large mass. If you want to go to the moon somewhere around 220, 230,000 miles. Now, Scott said if you want to go to Mars, which NASA administrators keeps talking about, that's approximately 23 million miles from Earth, and so that's quite a journey. Any questions?
Don't be shy, guys.
That makes it easy. No.
How much of the SLS is reusable or recoverable?
Just the Orion spacecraft is recoverable.
Are you going to reuse it, or is that just a one-time use only?
It's reusable. You know, again, it's a 3-program system. Marshall's responsible for the vehicle. JSC is responsible for the Orion spacecraft and the manned portion. So the Orion spacecraft will splash down and will be reusable.
You were talking about reusable. Don't you reuse the boosters? Because you did reuse them for the shuttle system.
We reuse the boosters on the space shuttle, but for SLS, we have no plans to reuse them.
Can you say why? Is it too
Just
complicated?
with the 5 stages, we looked at, you know, again, we're going to go to a new upgraded booster format. So we have enough hardware left over from the space shuttle to do our first 2 launches using the boosters we currently have, and there's no benefit to reuse them.
I see.
I got a question for you here. So how does this rocket compare to the Saturn V?
The SLS, when I say it's the biggest rocket, it's about 10% more thrust at liftoff than the Saturn V was. So it is quite a bit more capable than that. You know, we try to make it sustainable. Again, the payload fairings, you know, right now we have Orion in there, but we want to have it so you can launch large telescopes, large science missions to Jupiter, Saturn, whatever. It's trying to make it as diverse, sustainable, and affordable as we possibly can.
Doug Decco, Lofty Ambitions blog and Knox College Magazine. With the 10% increase in thrust, has that done anything to change the pad to firing room safety margin?
I think that would be more of a Scott question there. Launching with the added thrust and the capability of a SLS vehicle, does that put the LCC in the blast zone?
No, I think we're fine. Basically, we've sighted it all the way back to Saturn. Is the blast debris area, the BDA we call it, is there's plenty of margin there. We're okay.
So question for you. I know the current schedule calls for first flight 2017, second flight I think EM2 is 2021. Is there a concern about the lapse between unmanned and manned mission in terms of staleness of data, the workforce, so on and so forth?
Well, I think we're going to be doing constant upgrades, like I've said, between the boosters, the engines. So the workforce at KSC is going to be upgrading their facilities. The design teams up in Huntsville are working on flyback boosters, and I think there's enough work to keep everyone busy for years to come.
James Dean with Florida Today. It sounds like you're going to have a lot more capability than you need just to launch a crew inside Orion come 2021, and certainly for missions that follow. So is there any expectation for, you know, will you be lifting more than just Orion? Will there be systems, hardware you need to complete missions once they're out in orbit? Or
well, I think 2021 trying to send a manned crew around the moon will be pushing the SLS capability. There won't be excess capacity.
Okay, I thought there might be, but moving forward, the intention obviously of evolving to a larger vehicle is that you would be lifting landers and other systems in addition to a crew capsule.
Yeah, hopefully we'll be lifting larger structures that will be mated up in space to take the mankind into deep space somewhere, wherever the American public and the president directs us to. This vehicle will give us that capability to do that.
This is Robbie Adams from Knight Foundation. Are there components that are waiting to be lifted to the International Space Station that this would be capable of lifting that you don't maybe have the capacity for with current systems?
Right now, we don't have any plans for that. Like we are relying on our commercial partners to haul up the astronauts to the space station and bring them back down and haul up science back and forth.
Thank you.
Are there any other use cases driving the development of the SLS besides Mars?
Well, I think it's diverse enough where it could go anywhere in deep space. If you want to go to the moon, Mars, Lagrange points, anywhere that we are directed to go, this vehicle will take us. I think we have an overall goal. We'd all like to go to Mars, but we need some clear direction for that.
Thank you.
Any other questions?
Thank you very much.
All right, thank you all. Okay, next up from the Commercial Crew Program, we have Lisa Colorado. She's the Associate Manager of the CCP.
Okay, thanks. It's kind of unfortunate we have a name like Colorado. It sticks out. We couldn't have Smith or something, where y'all didn't know. There's like a couple thousand civil servants out here, and every once in a while, both of us line up. Neither of us knew we were both speaking in this until we saw the agenda a couple days ago. And I'm like, are you talking at that? So, but I'm from the Commercial Crew Program. We're relatively new here at Kennedy. The program was formed a couple of years ago, so we're central here and we reside here, the program does. But we have about half of our people at JSC also, so it's really across the two programs. Our whole mission is about getting our U.S. astronauts to the space station. So after, and I know that's why y'all are here, after the shuttle program was retiring, they decided that we would have to rely on the Russian Soyuz to get our U.S. astronauts back up to the station, and we do that now, and we will until we have our capability ready to go. And they're great partners, but it's not a good place to be to have one provider for that kind of service. And we have a lot of work going on. You heard earlier from the SLS MPCV, they have like 3 programs kind of running one vehicle. We have kind of one program running 3 vehicles right now, and I'll explain more. We're kind of give you a background on where we are in the whole progression. So we started with agreements to have what are called commercial crew development. We had CC Dev 1 and CC Dev 2. Those were commercial crew development 1 and 2. We had agreements with different commercial industry. And the first round was all about developing concepts. And then the second round was more on subsystem development and mainly around the spacecraft itself. We're now entering in, we awarded a new round of agreements to 3 partners just a couple of months ago in August. And those are all the integrated systems. So this is the first time we have it. It's centered around the launch vehicle. They have to have an integrated system with the launch vehicle, the spacecraft, the ground systems, mission ops, the whole thing, all the way from start to finish. So that has just started, and we have 3 partners that we have that are in work, and one is Sierra Nevada Corporation, the other one is Boeing, and then SpaceX. So I wanted to, and then pretty soon we're going to be going into this NASA certification process. So right now it's the design and development of the systems, and soon we're going to enter into the NASA certification of those systems. So again, ultimately what we want to do is buy a ride. So eventually that's where we're going to get. So before I go any further, I did want to show you a video of our 3 partners. I'm not really sure what this video shows, so I might have to talk through it. I don't know that I've seen it. Is it ready? Looks a little bit like a mini shuttle, much smaller. And what they're doing is testing their aerodynamics of their design. Learned a lot, making some changes as a result. And this is SpaceX's vehicle. It's the Falcon 9 and the Dragon. Probably seen this in the news lately. It's not quite the same. Ours is the crew version of that. What you've seen in the papers and read about lately is their big success on the cargo. So it's like the next evolution. And this is Boeing's CST-100. They're doing a drop test, and you'll see they're gonna test out their their airbags for landing. And this is their engine testing. I don't know, I guess we don't have the landing. Sorry about that. Like I said, I didn't get to see the video, or I don't know if I've seen this video. Yeah, there's the landing. So that's the airbags you saw kind of expanding there. Nice. I know you saw on the earlier video that the heavy SLS and MPCV were about on the same schedule, so maybe it's a little bit of a race for internally. Our schedule has us being ready around 2017 also, depending on the budget we get, obviously. But it's right around the same time that SLS and PCV, they're planning the same time, so we'll see who gets there first. We think it's going to be us. So where we are right now with the integrated capability, it's called CCI-CAP. Recently, just to tie it into what's going on at Kennedy, because I think that's the theme of transforming Kennedy here. Our Boeing partners just finished their production development review, and it was all about laying out the production capabilities that they're going to have here at Kennedy Space Center, converting what was the orbit processing facility, Bay 3, to their facility, which I think is called CC3PF, which is Commercial Crew and Cargo Processing Facility, I believe. And it was all about the production they're going to do. They're transforming and modifying the facility right now, tearing out some of the old platforms and things they don't need, clearing it out, building all their new. So that was just done this week. We are off and running. I can't tell you. I mean, as soon as those ICAP awards were made, our team, we have just been nonstop. There's a lot going on for 3 partners. So we had the production design review. All of our partners right away had what we call sort of a baseline review of their systems. Again, since this is the first time we're looking at an integrated system, this was their first round. They had some sort, called them different names, but basically they were all about putting together their plan for their integrated systems. And they had safety reviews are coming up the next round, I think, and most of them have some sort of safety review called something, and then different names. And then they have some of the ground software and the ground work is coming up in the ascent and launch and recovery work. So that's kind of where we are in the program. Like I said, we've come a long way. A lot of that video, hopefully you see that in the news. We're trying to do a little bit more with getting word out in public affairs. I know the partners themselves release a lot of press releases and all. The videos are out. We have a really good website that you can connect to, and you can see those videos and a lot of the work that's been going on and learn about the test. There's really a lot to talk about. Don't think I could do that in 10 minutes. So I guess I'll open it up to questions if y'all have any.
Seriously, don't be shy, guys. We'll start here.
Hi, my name is Ron Sparks. Question, you mentioned NASA certification for your commercial partners. Is that certification in order to lift our astronauts into orbit or to use the facilities, or how does that work?
Definitely for our astronauts, the safety of our astronauts. So once we get past, or we actually have a certification products contract that's being reviewed right now. The proposals are under review. Our overall process for certifying the whole system is going to be done in a two-phased approach. So our first phase is what's going on right now, and that's what's being reviewed. Will be followed with a second longer-term phase, and it's all about certifying that their systems meet our requirements, our safety requirements, and our performance requirements. So that's where we are as far as we're actually very excited because it shouldn't be that long. We're saying that first contract is to be ready to award in the February timeframe, so not too much longer.
Lisa, how many astronauts will the capsule hold?
Well, our requirement is for 4. Most of them have planned for more than 4, up to 7. Most of them have 7, and they're looking at, there's a lot of trades going on right now. Not sure all of them will stay at 7. But I mean, it's a good point. Our requirement is 4, but the whole commercialization concept is that they could use the vehicle for other non-NASA missions. So they could have their own use, to go for space tourism or any other use. And each one of them has kind of a different business model, I guess to say. But our requirement's for 4.
Would Boeing's capsule be capable of water landing as well?
I don't think so, not anymore. I know, again, they were doing trades, but it's now the baseline is land landing. And that's what you saw on there. They're doing testing. They did probably a week's worth of tests and, again, learned a lot. They made some adjustments in their airbags and have a center bag that they're going to be using to keep it upright and more stable. And so I think it's only land landing for now.
Are those safety requirements meeting those of the space shuttle, or are they going to exceed that?
Well, they actually exceed them. I guess it depends. That's always a big debate, right? We spent a lot of time in the program for probably a year and a half, understanding and leveraging off of the old shuttle requirements and what's changed and what's improved. So the whole technology has changed. So technically, I guess some people would view them and maybe say they're different. And our view is that they are definitely safer. They're different but safer.
Jonathan Yao, I was wondering, is there any future plans for commercializations past ISS, or is it just that's all that's on board right now?
Yeah, for our program, it's only for ISS or low Earth orbit. So there are some concepts, like I said, there's space tourism. So there someday may be a space hotel, a place to go, a resort to go visit and fly there for fun. But our vehicle and the performance is only for low Earth orbit. So there could be other uses. Our mission is really for our NASA astronauts. But like I said, the more market there is, the better it is for our customers, our partners. So they are all pursuing different markets. And it's hard to know, at some point, once you develop the capability, we hope, and it's expected to stimulate more market and more business and more ideas. So there's a good chance that it will. Mm-hmm.
Hey, Lisa, question for you about the man rating of Atlas V. Are you managing that through both Boeing and the SNC program, or are you doing that independently? I seem to remember something about there was an unfunded, I think a Space Act or something that went on with ULA on Atlas V. Could you talk about that?
Yeah, so you're talking about under CCDEV 2, we had some funded Space Act agreements, and we had some unfunded. And we did have an unfunded agreement with ULA. And so in ATK, I guess, well, we looked at it and we had some civil servants on it, but it was mainly about understanding and learning about what it would take to man rate and doing technical interchange meetings, having discussions. It was nothing binding. We have not really ventured down that other than to give them some of our benefit of our expertise and what we expect, and for them to learn and tell us what their plans are. But our like I said, our system will be certified to the safety requirements, and we will work through our Boeing and our primes. So we won't directly be interfacing with them and doing that, but we have to make sure the whole entire system, including the launch vehicle, has the right.
So you'll look at Atlas V as a component of both complete systems independently. You won't look at it as a separate component.
No, it will be part of the whole system. We do have teams. I mean, we have our organization is set up so that we have a launch vehicle systems office and a spacecraft and a ground. So, in effect, we will have some different groups, but in the end, we have to certify the whole system.
Thank you.
Mm-hmm.
If there is a change of administration next week, how do you see this affecting or not affecting business, or slowing it down, or what do you see?
Yeah, that's the $1 million question, right? We've been there before, and things can change. It's hard to say. Yeah, it really is hard to say. I think there's a lot of support for the commercial market, the commercial space market in general. We have some commitments already made, so I don't think those will be disturbed. The work that's going on right now will remain to see. We'll have to remain optimistic and just wait and see what happens. But either way, we'll adjust. We'll just have to do whatever the administration has decides is our future. We'll adjust and make plans. So I'm hopeful that we'll stay on track. It's a good question, though.
Hi. Is there any way that NASA has grown the program through their partners and ideas, or vice versa, or any collaboration?
That is like the whole underlying, I guess, foundation of our program. And you notice we call them partnerships, which is true, it's intended to be a partnership. We have done so many things that are innovative and different from maybe some of the historical programs, manned space programs. We have teams, PIT teams that work with our partners. So we have a PIT team, a partner integration team that works with each of the partners, and we are in constant contact with them. We meet, our teams meet daily to understand where their risks are and where they are in the process and how we can help, and the expertise we have maybe in-house. We have done a lot of things even back when we were writing requirements, our programmatic requirements. We had several forums with industry there to say these are our proposed requirements as we had them back before they were baselined or approved, and asked for feedback, and we got a lot of feedback. And so, we have really tried to include industry in a lot of our progress and decision making along the way. And so I would definitely say it's more of a partnership. Mm-hmm. And in the innovation, I don't know if you notice, when you pick it up on the video, how different the three different commercial transportation systems are, just even looking at them. They're it's it is kind of amazing when you put out kind of the same requirements to all the industry, and they come up with 3 very different looking and functioning and different philosophies behind their system. So it's been good. Challenges both sides, I think.
To be last question both times. Is there any concern about the commercial crew program and the press it's getting, especially with SpaceX, overshadowing what NASA's doing internally with the SLS?
I don't know. You're asking probably the wrong person. Me personally, I think any success is good for the space industry in general. So we root for them, just like, we work with our counterparts for the station, and anything that helps and anything that brings up the whole level of the community, the space community, the commercial industry is really, we see it good for all. So I don't know that we would ever think that it's, a competition in that sense. Now, some of the press is in here makes it come across a little bit that way in my view, but that's not kind of our program. Look, we would love to see more success. As many that we can have is actually better for the whole program and better for the agency. So and the country.
Thank you very, very much.
Mm-hmm.
Up next today is Bruce Reed. He is the Kennedy Space Center mission manager for the Landsat Data Continuity mission, which I don't know if you all have been following along, but we announced that we're going to be doing a NASA social at the LDCM launch out at Vandenberg Air Force Base coming up in February. So if you haven't seen that yet, please go to www.nasa.gov/social and go ahead and we'll look out for registration in December. So here to tell you a little bit about what they're doing to prepare for launch, here is Bruce.
Thank you, Jason. And thanks for opening up the social to people not named Colorado. I just want to start by telling you a little bit about what the Launch Services Program does. So we've talked a lot about the manned programs here today. The Launch Services Program is the middleman between the spacecraft and the launch vehicle. So our job is to procure the launch service and to select the appropriate launch vehicle. And of course, this is based on the size of the spacecraft, its destination in space, and of course, how much it weighs. So for our spacecraft customers, we provide a lot of technical guidance, and this is over a period of 3 to 5 years. So they'll need help with what are the interface requirements, how do I fit mechanically and electrical on this launch vehicle payload adapter, and I'm sure most of you are aware of the recent missions that we have had and overseen. We had RBSP, radio belt storm probes, in August of this year. Also, the New Star mission was launched from Kwajalein. That was off of the air-launched Pegasus rocket. And I was the mission manager on Grail last year. That was the Gravity Recovery and Interior Lab mission. We put 2 satellites in orbit around the moon. And of course, the one that you saw in the video earlier, the Mars Science Lab, launched in November of last year. So my job is to, I'm the primary point of contact for the spacecraft customer, which means I'm the complaint department, actually. But I have what we call a mission integration team. So it's a team of senior level engineers and business people. And we guide the customer through this process. So our ultimate goal in the Launch Services Program, which is based here at KSC, is to maximize mission success. That is our goal. The program has been here since 1998. So what I really wanted to talk to you about today was the Landsat Data Continuity mission. It's launching on February 11th from Vandenberg Air Force Base. And we're going to show a short video here about what LDCM means to the everyday person.
In 1972, a satellite was launched which will help to manage world agriculture. Landsat, the Earth Resources Satellite.
Today, over 7 billion people and their use of technology create drastic changes to the land surface and how resources are applied. In 4 decades, Landsat satellites have revolutionized remote sensing by collecting the longest historical archive of land change images worldwide. Launching LDCM and continuing the Landsat mission is critical for the large number of government and private data users worldwide. For the Robert Mondavi Winery in Napa Valley, California, Landsat plays a major role in monitoring 400 acres of land. The raw satellite data gets processed externally as a weekly report. The Landsat imagery and data in the report show color-coded comparisons of water usage, leaf growth, stress levels, and other measurements from the current and past years, as well as detailed graphs with the condition of each vineyard block. Based on this information, managers can plan care for the vines now and also in the years ahead.
The Landsat image allows us to understand and quantify how many leaves there are in a vineyard. And once we know that, then the people we're working with, they can make calculations of how much water that is. We can compare it to other vineyards. Are we using too much or too little? Are we applying it at the right time?
One of the major advantages for the winery is the use of continuous data to help make long-term decisions in planning. Among many other uses, Landsat data is applied in managing millions of acres of timberland. Using a specially designed tool, workers at American Forest Management are able to analyze satellite data and estimate the leaf area index. This index shows the concentration of needles on pine trees.
Once we process the raw product, we're able to create maps for clients, which allow them to analyze the data, look at stands that have high or low leaf area index. Based off that number, they're able to make management decisions, whether it's beneficial to fertilize or possibly do some hardwood control on a stand to make it grow stronger, faster, healthier.
Landsat provides a quicker solution to pinpointing problematic areas so they can be further analyzed on the ground. In contrast, collecting data on the ground or by airplane involves more manpower. It is slower and comes at a much higher cost, which makes this series of satellites irreplaceable for many years to come.
Okay, I've got some slides to augment that video. You did notice on there that it is wine country if you needed another reason to go to the NASA social during the launch. Yeah. Okay, can we get the slides up? Okay, so it's a joint mission, NASA and the U.S. Geological Survey. We're going to study, predict, and understand the consequences of land surface changes. I mentioned the launch date on February 11th, 2013. We'll be launching off of Space Launch Complex 3 at Vandenberg Air Force Base. And the launch vehicle, the launch you see on the screen there is one of the National Reconnaissance Orbiter missions that launched on, I believe, September 13th of this year. So that was Complex 3 there. And the launch vehicle is United Launch Alliance Atlas V 401. So it's a 5-year mission. That is our design goal, is 5-year mission, but we have 10 years of propellant with hopes always to exceed that design. The satellite system elements consist of the spacecraft, of course, which provides all the guidance for the satellite on orbit. And then we have 2 instruments. The operational land imager is built by Ball. And the thermal infrared sensor is a in-house NASA-built instrument at Goddard Space Flight Center. Once we get on orbit and the satellite is completely checked out, it'll be transferred to the USGS. The operational orbit is 705 kilometers, 438 miles. It's a near polar orbit. And the orbit period is 98.9 minutes. So we'll do a complete revolution of the Earth about every 100 minutes. And then every 16 days, we will have completely mapped the Earth and then start that cycle again. So the swath of that is about 114 miles wide as it passes over the land. So this is, just to give you an idea of the Landsat legacy, we've been doing this for over 40 years now. So we have 40 years of continuous data. We launched Landsat 1 in 1972. And again, continuous data. Landsat 5 was just taken out of operation in November of last year. And Landsat 6 failed to reach orbit, but luckily we had Landsat 7 on orbit. And Landsat 7 is 7 years beyond its design life now. So it's still functioning. It's got some instrument degradation, but it's still in orbit and still returning data. But that is the need for LDCM to go ahead and get it on orbit so we can continue that data collection. So land cover and land use, they're changing at unprecedented rates, driven, of course, mainly by population and climate. And we all know that's only going to accelerate going forward. And it has profound consequences on fiber and food production, water resource management. There's 13 Western states and 26 countries that use Landsat scenes for water resource management. And you saw in the video there, they're using it to help with their wine crops and grape crops. So also we'll be giving feedback to the physical climate system, atmospheric carbon, and also energy balance. So we're living through accelerating changes in land use, resource availability, and ecological health, and we need to monitor these changes so we can prepare for future trends. And this Landsat program fills a critical niche in the architecture of land remote sensing and geospatial technology. So making Landsat program operational is the best way to guarantee continuity of land monitoring through the 21st century. So the EROS Center, the Earth Resources and Observation and Science Center, it's in Sioux Falls, Sioux Falls, South Dakota. I knew I was going to do that. And on the left there is a picture of that center. And they, all the data is downlinked and stored and distributed by the EROS Center. Next slide. So right now, the USGS has over 3 million Landsat scenes. And again, that spans almost 40 years. And up until 2008, this data was fairly expensive. And then there was a change in policy. And so this data is now free. And the distribution has gone from 25,000 scenes per year to over 3 million scenes per year. And the U.S. is the only nation that's really committed to preserving this multi-decadal record. Next. So this is the launch vehicle. It's built by United Launch Alliance. On the left in the picture, you see the LDCM spacecraft surrounded by the payload fairing. The payload fairing protects that satellite on ascent. It'll be, the configuration is an Atlas V 401. We've got a single Centaur engine, a single RL-10 engine on the Centaur, and a Russian-built RD-180 engine on the Atlas booster. We have an onboard video system, so we'll be streaming live video on ascent. We've got a camera that's on the booster facing up, another one facing down, and then we've got another camera on the Centaur facing up. So we'll be able to see the satellite separate from the launch vehicle. And just some facts there. It'll be the 37th Atlas V launch. So in summary, the current launch date is February 11th. The spacecraft is in the thermal vac chamber at Orbital Sciences Corporation in Gilbert, Arizona. We're planning to ship on December 18th of this year. And then we'll do the final spacecraft processing, things like battery charging and that at the Astrotech facility at Vandenberg. Astrotech, for those that don't know, is a commercial payload processing facility, and it's used to process payloads for the Air Force commercial payloads and also NASA payloads. So the launch vehicle activities are on track. If you go to Select 3 right now, you'll see the LDCM launch vehicle is already stacked at the pad. They're doing their electrical and mechanical preparations for our launch on February 11th. And lastly, we have some Landsat websites for reference in case you want to do a little more research. So that's all I have for you. Any questions?
I'm Tracy Larvans from San Diego, California. By the way, February 11th is 3 days off my birthday, so I'm
Okay.
close. So just so you know,
We'll celebrate it.
There we go. But my question for you is: we talked mostly about agricultural uses, but does it also keep track of things like sea ice and the glaciers, that sort of thing?
Yes, it does. You know, the interesting thing is, since the data is free now, we're finding people are out there that are able to obtain this data are finding more and more uses for it. So we are able to determine quite a bit just from the thermal infrared sensor and also the land imager. So it is being used for that purpose.
I'm Mark Ratterman with Talking Space. A question for you about what happens from launch to orbit and when a satellite's turned over to the user. What kind of checkouts are done? Is there changes in the instruments and how they read, or is it just verifying that they work?
Yeah, it's mostly verifying that they work. Incidentally, I didn't talk too much about that, but the separation from the launch vehicle will be 1 hour and 18 minutes after launch. And then, you know, I was also on the NPOS preparatory project, which launched from Vandenberg last October. And it took them about 3 or 4 months to completely check out the satellite. So they run through a series of tests and also how you communicate with the Mission Operations Center. So there's a lot of checkout that needs to be done before you're confident that they're not going to have any issues once it's turned over. At that point, once it's turned over, it should just be for use. So.
Hi, I'm Jonathan Yao. I was curious, is the Landsat, it's continuous image capture or is it task-based?
It's continuous image capture. So we'll be in a polar orbit, and every orbit only takes about 100 minutes, and it's 114 miles wide. So you continue that and changing your clocking around the Earth, and 16 days later, you have completely mapped the Earth. And so whether or not all those images are stored and whether they would even be able to accommodate that, that I'm not sure of. But yes, it's a continuous mapping, and so that's what we plan to do.
Hi, I'm Kelly Hedgepeth, and I was just wondering, you have said a couple of times the data is now free. Is there any future thought into commercializing the data?
That's a good question. I am not aware of any. Landsat's motto is free data for a free society. So, you know, it's the data is so valuable, and, you know, really what it's all about is preserving our resources and managing our resources here on Earth. So I'm not aware of anything in the works to commercialize that availability.
Hi, it's Laura Bloom. Is it visible from, can you see it go over, or is there a way to know where it is?
Well, certainly online you could track it. I would say it is not visible, if you look at the altitude.
Hi, Ron Sparks. What kind of quality and resolution can we expect from this camera?
I don't have those numbers off the top of my head. I can get those to you. It's funny you mentioned that because I originally had them on the chart. And we thought, well, that's too much technical detail. So, so see me after this event.
Other questions?
What's the difference between launching this out at Vandenberg Air Force Base versus here at the Cape?
Well, we're going into a polar orbit. So if you look at a globe and you look at the geographical location of Vandenberg Air Force Base, you launch due south. You don't go over any land. And it's the most efficient way to put a satellite into polar orbit. So from Florida, we tend to launch satellites into equatorial orbit, and we launch directly east.
Other questions? All right, thank you very, very much.
Thank you.
So this concludes today's portion of the NASA Social on NASA TV. Just want to remind everybody that you can follow along with NASA. We're at NASA on Twitter. On Google+, we're +NASA. And on Facebook, you can find us at facebook.com/NASA. We also are on YouTube. We Ustream a lot of our events and things like that. We're on Flickr. We have podcasts all over iTunes, so you can find us all over social media. If you want to find where all of our accounts are, you can go to www.nasa.gov/connect and connect and collaborate with us as we go about exploring space. So thank you all very much for following online. Again, tomorrow's hashtag for the Atlantis rollover is #Atlantis. And we look forward to having a successful move of the space shuttle. So thank you all very much for joining us today, and thanks for following online. Have a wonderful day now.